Look closely at any modern airliner. Every window, without exception, is round. But why? This simple, geometric decision holds one of the most critical and dramatic stories in aviation history. We see them every time we fly, yet few of us ever stop to consider this profound engineering detail. It's not just an aesthetic choice, it's a matter of life and death, forged in disaster. That small, rounded opening separating you from the vacuum of 35,000 feet is the result of a catastrophic learning curve that changed the face of air travel forever. Join us as we uncover the true engineering mystery behind the round airplane window and the forgotten disasters that led to its invention. In the 1950s, the aviation world entered the glamorous jet age. Suddenly, commercial flight was faster, higher, and promised luxury. But those higher altitudes introduced a new, deadly threat. Early jets needed pressurized cabins to fly comfortably at high altitudes. This pressure difference, however, put immense cyclical strain on the aircraft's fuselage. Then came the disasters. Two de Havilland Comet jets, the pride of British engineering, broke apart mid-air in 1954, separated by only months. The world watched in horror and confusion. A massive investigation began, headed by the world's leading engineers. They were looking for an engine failure, a structural fault. But the truth was far simpler and far more insidious. Engineers rebuilt the wreckage, piece by piece, conducting water pressure tests that simulated thousands of flight cycles. They needed to find the invisible killer hiding in the structure. The shocking discovery was that the metal of the aircraft body itself was failing, not due to sudden force, but through a slow, microscopic process known as metal fatigue. To understand the catastrophic failures, we must grasp the physics of stress. Every time a plane ascends and descends, the fuselage swells and contracts under extreme pressure differentials. This constant flexing causes microscopic cracks to form and grow, particularly in areas where stress is concentrated, like invisible fault lines waiting to rupture. And here was the fatal flaw. The early Comet jets had square windows. Why were squares deadly? Because of their sharp corners, which acted as intense, stress concentrators? The engineers had found their answer. The corners of the square windows were the points where metal fatigue cracks initiated. A new design was desperately needed. The solution was elegant, yet profound. Replace the square windows with circles, or, more accurately, with the rounded rectangular shape we see today. In a circular or rounded shape, stress loads are distributed uniformly across the entire curve. There are no sharp points for microscopic cracks to take hold and grow. This engineering lesson, learned at a terrible cost, became the bedrock of modern aviation. The rounded window ensured that the cyclical pressures of high-altitude flight were managed safely. Today's cockpits, wings, and fuselages are marvels of material science and engineering, constantly monitored and maintained, ensuring safety on a global scale. The humble round window is a silent testament to the engineers who diagnosed a fatal flaw and provided the discovery that opened the skies for safe, global air travel. So the next time you board a plane, remember that seemingly mundane circle. It is one of the most critical design features keeping you safe. It reminds us that sometimes the simplest geometry, the circle, is the perfect solution to the most complex and dangerous engineering challenges. Thank you for watching and safe travels.